Hello, everyone. Welcome.
Hey.
All right. So let's take a look at the calendar quick. All right, so you should be seeing the calendar here. And today is April 18th. And that's basically kind of our last lecture today. And then we have presentations of your projects, individual projects next Monday. All right, and then we'll have the final exam probably on May 2nd. I believe it'll be probably at 2:45. No, yeah, 2:45. I think. All right, so let's take a look at today's. So I guess before I get started, are there any questions? Any questions?
Real quick.
Go ahead, please.
For the GPT-2 homework, are we just getting it to work? Is that like?
So today we're really just going to wrap up the semester. And really, so the way that I'm going to do it, you can see I've gone to the to GitHub here, and I just want to show you basically what you can do further if you're interested in continuing to learn about transformers. So this semester I've been using this book called Mastering Transformers. And so I went to GitHub, and then basically we have gone through chapters 1 through 7, right? I've taken several topics out of that, and we pretty much finished it actually. Everything that remained, these are like not so important topics. Really the bulk of it was like 4 through 7, but I still wanted to point out some of these in case you wanted to look at them on your own. And then after that today also, we're going to talk about CNNs, and we're going to talk about the vision transformer. So I'm really going to wrap up with that. Just that's kind of like the state of the art. Obviously, we've used CNNs via ResNet this semester. I'm just going to explain the algorithm. You've already used it, so you know how to use the code. So the idea, if we look, let's say at chapter 7, the last thing we looked at was like sentence similarity experiments. And then these two Jupyter notebooks that you see here, I was actually running this. You can see, oh, wait, this actually finished. All right, yeah, so I was running this script on my own. And basically this is the sentence text clustering with sentence BERT. So the idea here is to do clustering with, with text, right? But using BERT to be able to do the clustering. So here we can use something like k-means. So if you remember from 365 or from 520, we learned how to do clustering. So here we can do clustering, but now with sentences. And we're going to leverage BERT. So you can see you install sentence transformers, and then you install data sets here. And we install some libraries like pandas, torch, etc. This is going to be done with a data set called Amazon Polarity, which is, it's like a polarity data set from Amazon. It is really large. This is a really large data set. So it took me a while to download this. And you can see here, if I run, that's the data set itself. It's got labels, titles, and content. You can see the number of rows here is like 3,600,000. Are you guys seeing this?
Yeah, we see it.
Yeah, so all I'm doing with this example, I think it's pretty obvious now because it's similar to what we did before. But instead of comparing two sentences, we're just going to do clustering here. You slice out just a few samples, given that I'm doing this on my CPU. So we run that. We've got the corpus, we shuffle it randomly, the content. So we've got the sentences. Then we can do a histogram of the length. Notice it's the length. We do a E. So for E in corpus, right, we grab all the sentences, then each sentence gets split, and then we do a length of each one, and then we do a histogram of those. Right, and you can see the histogram there to see the number of tokens. And then we have some models that we're going to run, the basic models. Okay, and you can see here we're using a Roberta model, but it's being encapsulated in a sentence transformer module, right? So this allows us to deal with sentences. Then we encode the corpus here, right? We can do that. Okay. Not defined. Oh, okay. So the problem is this is very big and it's very slow. So, well, I'm just going to jump to their GitHub. So you can see this one. And in their GitHub, they ran it. So I can look at clustering there. All right, and this is the same Jupyter notebook. So this is where we were, the filter. We run the model here. Then there's the size. So we've taken all the sentences to 10,000 sentences or so. And notice that they have now been embedded pretty much like we were doing the last time we met via BERT. Okay. And so now that we have the sentences, basically what we end up with is 10,000 vectors of size 768. So we're just going to do a clustering here and notice that we're actually just using sklearn. We're not even using anything very sophisticated. This is not KNN. Remember, KNN was the supervised learning. This is k-means. And 5 just means the number of clusters that we're going to separate the data into. All right, and you can see that here. We can proceed. This will list the number of clusters. So we got 1, 0, 1, 2, 3, 4. And basically, remember in clustering, you don't really know what the clusters are. So the idea here would be to grab sentences that are the closest to the centroid. Okay, and that's what this code is doing. And it's returning these sentences. So then basically by the words, we would be able to say what the clusters are for. So we proceed, for instance, to using this library to create do a mapping, do a transformation to 2 dimensions. So remember that the original dimension of the vector space here is 768. And we're going to reduce that dimensionality to just 2. And then these are the 5 clusters that it creates. All right, and actually quite clear. They got purple here, orange, green, brown, I guess, and light blue. And each one of these 0, 1, 2, 3, 4 can be loosely said to belong to these categories, right? So if we look at this, we would say that cluster 0 is mainly about the sound quality is not good. I used it once and couldn't take the poor audio. I bought this because a cheaper one. All right, radio comes outfitted. Then we have cluster 1. This album, like many rock albums, is good, but there's nothing innovative about it. Then the second one is this DVD looks nice and all, but is horrible because it skips. Then cluster 3, I read this book a while back and thought it was very interesting. And then the last one, the quality of this product is great, easy to clean, and fits my sink perfectly. However, I think it's a little bit expensive. So you can see it created what, 5 clusters. So just these, remember, these sentences are just sentences, one, a sample sentence close to the centroid. So now that you look at this picture and you've read these sentences, what would you say those clusters are about? Just by the sentences. What do you guys think?
They're music related, at least the first 2.
Right, but they're supposed to be like distinctive, right? Distinctive. So I would say probably one of these is about books, this one, right? So we could argue that cluster 3, which is this, is all about books, which kind of makes sense because Amazon sells a lot of books, right? And then we've got some, as you said, that were about electronics, right? The first one, or music. This one is about DVDs. DVDs are movies. And then the last one, what is the last one about, do you think?
Reviews.
It wasn't about reviews. No, these are all reviews, right?
Oh.
So what I mean is the clusters that we're creating, right, are about some topics or categories. So the last one, the quality of this product is great, easy to clean, and fits in my sink. So it seems to be like, cleaning supplies, maybe. Do you see what I'm saying, guys?
Yeah.
Yeah, so this is, like I said, this is literally like one of the last topics in the book. The last time we met, we talked about similarity metrics, etc. And today I'm just going over like some of the last scripts. So this one is how to do clustering, basically. So as you can see, we took the sentences from that polarity, Amazon polarity data set, which is really large. We used this model, distilled Roberta. We ran it to a sentence transformer, which allows you to process sentences together. Created the embeddings that created a data set of 10,000 sentences by 768. And then basically, we just ran it through a normal k-means clustering algorithm. Okay. And that gave us really clusters, right? So that's what I was talking about. So then we can plot the clusters by reducing the dimensionality from 768 to using this library here. But so you can see this basically create UMAP is a dimensionality reduction. You can see it's saying convert the data into 2 dimensions there, and that's your X, and then we just plot it. But just by looking at the pictures, we don't really know what it means. So that's why a good approach would be to look at some sentences close to the centroids, right? And then from those words, we can derive the different clusters that these represent. Like we did just now, books, cleaning supplies, and then all the other things. And actually, if you notice, 2 and 1 are kind of, no, actually it should be 0, 1, and 2, right? So they're kind of close together. So yeah, so that's an example of doing clustering. If you ever want to do that with BERT, now you can follow this code here. There's another idea of doing topic modeling. So that's specifically using BERT topic, right? So from BERT topic, import BERT topic. That's a specific version. You can bring in something like a Roberta model and then embed the model in the BERT topic, just like we did in sentence topic. And now this model basically will do kind of the same thing as clustering, but more specific for you. All right, and then it's going to give you some output of the individual topics that it has found. So notice how it's automatically taking words. So this one says book, read, books, my product, movie, film, DVD, CD, hair product, skin. So if you notice, we weren't that off, right? it's the same data set, but BERT topic actually figured out the topics for you. And if you notice, like we had said here that the first ones are like music, then there's one about books, and then the last one is about like bathroom products. And so here you can see it actually also found DVDs, right? And then here it's like books, and then it found skincare products, it seems, or hair products. So this is, yeah, so this is another, another technique, right? Whenever you want to leverage BERT to do clustering or topic modeling. So this completes or rounds out the unsupervised algorithms from chapter 7 of this book. Any questions on this, guys? Any questions? Does this make sense?
Yeah, I think it makes sense.
Yeah, so the idea is, basically that. So, today I'm just kind of wrapping up all the miscellaneous. And if you ever want to do clustering or topic modeling, you basically have a data set of sentences. You can discover, you have two approaches, either getting some sentences close to the centroid and figuring out the words, or literally using something like BERT topic, which is really the key thing, to get some clusters. So it's actually handy. And you can accomplish some tasks giving your text. All right. Okay. All right. So that's basically, I think that's all the scripts from chapter 7 of the book. So we did that. All right. Now, what comes after in the book for Huggin for these transformer models is chapter 8, 9, and 10, I think. Oh, 8, 9, 10, and 11. So this 11 is, yeah, so these chapters. These chapters are a little bit different. So chapter 8, I believe it's about like working with efficient transformers. So it's more like, how to improve on the algorithms, okay? So not so much about solving a problem, but just, finding efficiencies. So I'm not, we're not going to discuss this so much, but, you can take a look at it. Working with, efficient self-attention. So this just, gets into the specifics of the algorithm, benchmarking, memory, all that stuff, showing how well it's predicting, versus time and all that. So this is more about efficiency. So I guess if you're ever running into problems that are pretty big and, in your endeavors, right? And this might be a chapter worth going through, but, I'm not going to discuss it. I just wanted to point it out. Okay. The next chapter is chapter 9. We've gotten into that a little bit. So let's take a look. Chapter 9 is actually, if you look here, it's about multilingual, BERT cross-lingual. So it's all about language. And so basically translation. So the original transformer from the paper Attention is All You Need 2017 was actually focused on language translation. One of the most powerful algorithms for translation, or for multilingual learning, I guess, is XLM Roberta, which I think it means cross-lingual. XLM, cross-lingual model, I believe. Okay, and so that XLM Roberta, if you remember, was trained on 2.5 terabytes of data from 100 languages. And the idea is that because it's breaking the words into subwords, even though it only learns in, let's say English or Spanish or French, Icelandic or Greek or Hebrew, although it's never seen those words, you can break it up into syllables and language will follow certain patterns. So it's still able to do well on those languages. So the idea is to transfer for languages that are not seen so much, right? It's supposed to learn from the big ones and then be able to apply to the smaller ones. Okay, so this one has, this includes several scripts in here on cross-lingual text similarity, visualization, classification, and so on. Okay, so we can just kind of glance at them. So we're not going to spend too much time. But XLM, obviously multilingual. BERT, so this should be you can see here, basically you have some sentences in various languages. So I believe that obviously is English. I think the other one's Turkish and Arabic probably. And you can see how, it can do lots of things like mask token prediction, etc., but across languages. Now, what's important here to understand is that you train on, and you can see it's using Roberta XLM. The incredible thing about this is that you're training on multiple languages. And it's not like you're training on, okay, here's the English sentence and here's the equivalent Spanish sentence. It's just, you're just basically giving it English text and then some other, let's say from Facebook posts in English and then Facebook posts in German and Facebook posts in Turkish, Arabic, etc. And they're unrelated, but because it's doing the whole next sentence prediction or it's doing the whole mass language model prediction, it's just going to learn together all that data and be able to do transfer learning. So you can see this one here, it's doing the masking. So obviously, I don't speak this language, but I'm assuming, it predicted something for sure. It did the same here for Turkish, right? So it predicted apparently the word dogal. And so you can see that, this is just an extension of what we've been doing all semester, but the key thing or the key difference here to be aware of is that these models, Roberta XLM in particular, is trained on text from 100 languages and it's 2.5 terabytes. I think I showed you guys the table. Did I show you the table of Roberta and the distribution of languages? Do you guys remember that?
I think so. That was like 2 weeks ago. I think you did that, right?
I know it was 2 weeks ago, but that's basically the only thing that's kind of like relevant here is that it was trained on, totally different text from English, totally different text from French, totally different text from Russian. It's a lot of text and it learns really well. So it's pretty impressive actually. Any questions on this idea? No questions? All right, so these are just some of the examples in chapter 9. I wanted to, I guess, point out all this. So this is XLM multilingual BERT, cross-lingual text similarity. So you can see here similarities. That's an interesting thing. You can see here you've got English and you've got Turkish, I guess. Again, you encode the languages based on the model. So in this case, it's a fine-tuned XLM Roberta. So this is XLM Roberta, but this is for a specific task. Let me take a look. That task should be. You guys know what that stands for. Let me know. STSB should be let's see. Semantic textual similarity, all right, benchmark, right? So it's using that. So it's looking for semantic text similarity. So, you know, you encode the sentences and then you can see it's just like we were before comparing, you know, English to English. Now you're just comparing English to other languages and it gives you a score basically. So it seems like it's almost like a translation, wouldn't you agree? So if you look at the sentence, it says something TV, here's TV, this is talking about pizza. I assume macaron is pasta. So in a sense, this is translation because by doing the similarity, you're going to find the closest sentence in the other language to your original sentence. You guys see that? Does that make sense? You can see that example is being done here. And so what's important here is that across multilingual languages, you can also train a transformer. It's almost like a transformer that speaks other cultures, other languages, but it can still do the same tasks. Okay. Questions about this one, guys? Any questions? Nope. All right, let's take a look at another one. So that was these two. Here's a visualization one. So this requires obviously a lot of libraries, and you can see that UMAP for dimensionality reduction. Here we have some data sets. See, this is a collection of sentences and translations. This is Russian. And then this is English, source sentence, target sentence. So it's doing the same thing, sentence similarity. And you can see here, look at how nice this is. It's plotting sentences and their similarity or dissimilarity. Okay. So you can see that there. Let's see, this is, so most sentence pairs here are located close to each other. And you know, that kind of tells you that it's, I assume Russian 9 and English 9 are, you know, the translation of each other. So let's, well, I don't understand Russian. So. But yeah, so that's kind of the idea here is visualizing similarity of sentences. So you can also do that with the models. And then you have things like zero shot, which if you remember, zero shot is when you have no fine tuning, you just use the model, or you have very little fine tuning data, which is called few shot. And but still the model is able to do some kind of prediction. Here you have some fine tuning of models. So we can take a look at the classification one. So this uses IMDb, so it's probably something related to sentiment analysis or movie reviews. So here we have some other data set and some language. Okay. You're going to do some so this is the transformer model. Then you encode X train X test and the language itself. And here you're building an actual neural network with Keras. Okay, so you fit the model. And then you're predicting some kind of a value here for classification. Okay, so yeah, so these are just some of the examples you can take a look at. related to language translation. So that's chapter 9. Let's go look at chapter 10. This one is also a chapter that is just, it has to do with Docker and things like that, how to serve transformer models very efficiently. So I'm not going to get into that, but obviously you guys may want to read through this, okay? So here it's got Fast AI, that's some kind of a library, right? Which it's like a way of wrapping your transformer for fast deployment. Okay, so I've not worked with this, but you guys can explore that on your own. I believe there's one for Docker. So here's for those of you that are experts in Docker, right? You can take a look at how to Dockerize, I suppose, your transformer models for easy deployment. And then there's a few other things as well, using Locust, and various other tools. So I'm unfamiliar with Locust, but you can, right? So you can explore that if you're interested. And then the last chapter is chapter 11. And chapter 11, this one is actually an interesting chapter that of all these chapters after the clustering, this one is kind of interesting to me because it's about visualizing the attention mechanism. So if you remember, we said that attention is basically the mechanism in transformers that pays attention. So it pays attention between the words, right? So you're going to have a matrix and you're going to create the embeddings, and then those embeddings get projected basically into 3 vector spaces. And then you're going to compare those, the keys, the queries, and the values, and see which terms are related to each other, right? So this is nice because mastering, hopefully, these functions would allow you to take a problem and visualize the attentions of it. So for your term project, actually, if you guys feel that there's one thing that you want to apply to it, I would say it's this, okay? So what I mean by that is, whatever project you're doing, right, you could maybe implement these tools and they would allow you to, should be some graph here. Okay, not here. Let's take a look at this one. Okay, not that one either. This one. Or that one. All right. So, but basically, I'm looking at the book here, and in the book, they do visualization of the attention mechanisms. So let me see if I can find a reference for that. So this, I've not used this either, but it's definitely something that I would be interested in learning in the future. So it's going to be transformers visualization of the attention mechanism. So BERT-Viz is the one that we actually looked at before. And yeah, something like this. You see that? That's really neat. And the book was getting at that, BERT-Viz, you just didn't have anything. And what seems to be great about this is that it's going to show you some visualization of how the neural network is working inside. You guys see that? So it's highly a very complex thing, obviously, but BERT-Viz actually seems to be a place to start. Obviously, I'm not saying that you do this for your project. I'm just saying that as you learn more, certainly you would impress a lot of people if you know how to implement this in your models, because a lot of the time explainability is really important, right? And so this one, BERT-Viz, if we go back to what they have here in chapter 11, here it is, BERT-Viz. So they were actually Okay. Maybe that's what had happened, that it just took too long to render. Let's see. There's an error there. Yeah, so they're using BertViz here. You can see that. And then they wanted to do some kind of visualization. Not sure why it's not printing on their end, but anyway, you can actually go to the BertViz GitHub, and they're basically showing BertViz is an interactive tool for visualizing attention in transformer language models such as BERT, GPT-2, or T5. It can be run inside a Jupyter or a Colab through a simple Python API that uploads most Hugging Face models. So that's really great. And although, after the clustering, if you guys, obviously, as you go forward, right? I don't mean the class is pretty much over at this point, but going forward, you guys can start leveraging these things. Extends the TensorFlow visualization tool, providing multiple views that each offer a unique lens into the attention mechanism. So it does use tensor to tensor visualization tool here. And then you can see head view is a module there that visualizes attention for one or more attention heads in the same layer. It is based on the excellent tool here. And then you can see how it's showing which, most likely the darker links are the stronger weights. And it's showing how rabbit, probably related to the and hopped, and then there's the turtle, and then the here should connect to turtle, and so on. And then here there's, this is a bird's eye view of attention across all layers and heads. So you can see how this is pretty much everything. So it can be a lot, and maybe it's not meaningful, but it's certainly, especially for those of you that are doing research. I don't know how many of you are doing like a master's in our program, and if you're using transformers in your models, this would be really great because it would go into taking away the black box that is attention and just diving a little bit deeper into it. This is the neuron view, which visualizes individual neurons in the query and key vectors. So that this is, pretty impressive here. So you can take a look at that. And then these are the instructions on how to load it and a sample code. Okay. Yeah, so certainly that's one topic that is pretty interesting. And that's actually the entire book. The book has 11 chapters. This is the book that I used this semester, if you remember, this one for the NLP part, and then I used a fast AI for the vision part. All right, so let's go back here. If you guys are seeing this, go back to the last chapter in the GitHub. So BertViz, and then there's these other tools. TensorBoard is actually from TensorFlow. So I don't know if you can use TensorBoard with PyTorch. That's the only thing. I believe you can, but I'm not sure. But I think the other BertViz should be independent. Yeah, so I'm not seeing TensorFlow in here anywhere. All right, so anyway, that's kind of the tools that we have available. And then the last one is, so the last one is that last tool. Sorry, I went to the wrong place. Chapter 11, this 1B. So that's probably something else. Tracking BERT fine tuning. All right, so another tool there for visualization. but I've never used this one either. So it's something that you can certainly take a look at. Yeah, so that's basically the book. Let's do so let me go.